Okay, so this is the second video for Leaving Cert Calculus. In the first video we looked at the first and second derivatives. So we're going to use those two to move on with the rest of the chapter. So this video will be slope of tangent, maximum and minimum points, and increasing and decreasing functions. So first of all, the slope of the tangent shows this rate of change, and we said that differentiation was studying the rates of change. Okay, so we're going to start off by differentiating when we're talking about the slope of the tangent. So let's just discuss tangent again. So a tangent is a line that hits off a curve at one point only. Okay, so this question is basically saying that this function, this is the graph of this cubic function, and it's saying it has a tangent at 0, -3. Now 0, -3 is this point here, and a tangent basically means that there is a line that hits off one point at one point of the curve only. Okay, so it's not a line that's going to go through here, because that would hit 2 points of the curve, or 3 points of the curve even. Okay, so a tangent, first of all, is a line, and it hits a curve, or if we were studying the circle, at 1 point only. So this is going to show us the growth or the decay, so the rate of change that this is happening. So we need to differentiate first of all. Okay, so every time you see slope of tangent or dimension of a tangent, first thing you're going to do is differentiate. Now they actually tell us in this question what to do. So f of x is 2x cubed plus x squared plus x minus 3. So f prime of x is the first derivative. So 3 times 2 is 6x, and reducing the power, so it becomes 6x squared, plus 2 times 5 is 10x to the power of 1. This is like plus 1x to the power of 1, so 1 times 1 is 1. Okay, and remember from the previous video that would reduce from x to the power of 1 to x to the power of 0. X to the power of 0 is the same as 1, because anything to the power of 0 is 1. So this is our final answer. Because there's no x here, we don't differentiate it. That's the final answer for part 1. Part 2 says find the slope of the tangent at 0, -3. So what you do for the slope of the tangent at this point, which is an xy coordinate, okay, we are going to sub in the x value to the derivative. So the x value here is x equals 0. So we're going to sub that in. So 6 times 0 squared plus 10 times 0 plus 1. And if we work that out, we have 0 squared is 0, 6 times 0 is 0, plus 10 times 0 is 0. So my answer for the slope of the tangent is 1. Okay, now my picture is not really reflective of that, as you can see. So don't worry about that, but if that was a proper picture, mine's just a very quick sketch, but if that was a proper picture in an exam, you'd be looking at like checking rise over run for the slope, and it should obviously match your answer. Okay, so yeah, that's slope of tangent. We'll do one more example of that. Example 2 says f of x is equal to x squared plus 2x plus 1, and it says it has a tangent at 0, 1. Now, first of all, there's no picture here, so I'm trying to visualize what's happening. If you remember when we did functions, an x squared, a positive x squared function is going to be u-shaped. Okay, so again, just a quick sketch, u-shaped graph, because it's a plus x squared. Okay, Now, the 1 here at the end is where it cuts the y-axis. So that's why I've drawn this. So it looks like the function cuts the y-axis at 1, okay? So what they're saying here is this function has a tangent at 0, 1. So my tangent line now goes through that point 0, 1. So the tangent looks something like this. Again, I should be using a ruler. I shouldn't be scribbling like that. But you get the idea. This is the point where we have our tangent and we're going to find the slope of that tangent line. So it tells us again what to do. Part 1 says write down f prime of x. So what we have here is f prime of x is equal to x squared becomes 2x to the power of 1. And then 2x to the power of 1 becomes plus 2, x to the power of 0, which just becomes 1. So that's my answer to part 1. Okay. Part 2, find the slope of the tangent at 0, 1. Okay, so we now have our linear function 2x plus 2, and we're now going to find the slope. Remember, this is our x and this is our y, and we're going to sub in when x is equal to 0. So we have 2 times 0 plus 2, which means 2 is your slope of the tangent. Okay. Next, we're going to do an example of increasing and decreasing functions. So, what we're looking at here is when our function, okay, when we look at our graph, at what stage is the function increasing and at what stage is the function decreasing, okay? So f of x increases when f prime of x is greater than or equal to 0, okay? So again, we're going to be looking at the derivative of functions. So it's increasing when f prime of x is greater than or equal to 0. And f of x decreases when f prime of x is less than or equal to 0. Okay? Another way of saying this, increases when the y value is increasing and the x value is increasing also. And then decreases when the y value decreases as the x value increases. Okay? So these two are probably the most important parts. And we're going to use this idea when we look at an example now. So in the example, it says f of x is equal to x cubed minus 3x squared plus 1. Okay, now in this question they say find f prime of x, but they might actually just ask find the range of values for which f of x is increasing, and you would have to know that, okay, I need to differentiate first. Okay, so let's do part 1 and we'll differentiate. So x cubed minus 3x squared plus 1. So if we differentiate that, we've 3 times x, so it's 3x. Reducing the power by 1 is 3x squared. Minus 2 times 3 is 6x, and reducing the power by 1 is just 6x to the power of 1. And remember, 1 doesn't have an x, so we're not differentiating that. So the first part is 3x squared minus 6x. Okay. What we're going to do then here, the reason we're letting f prime of x be greater than or equal to 0 is because the question asks find the range of values for when f of x is increasing. Okay, and if we go back, it says increases when f prime of x is greater than or equal to 0. So I'm going to do that. We found f prime of x in the previous part, which was 3x squared minus 6x, and I'm going to let it be greater than or equal to 0. Now what we can do here is we have a quadratic, and we solved quadratics in previous videos in algebra. So this one here we're going to solve using the highest common factor. So the highest common factor here is they both have a 3 in common and they both have an x in common. Okay, so 3x, and we're left with x minus 3 times 2 is 6, is greater than or equal to 0. letting each bracket be greater than or equal to 0. So 3x is greater than or equal to 0. X minus 2 is greater than or equal to 0. 3x, remember, is 3 times x. So if we leave x on its own, the multiplication becomes division. So x is greater than or equal to 0. Okay. And x minus 2 is greater than or equal to 0. So x is greater than or equal to 2. Okay. Now, this is probably the most important part. Comes up a huge amount. And I suppose I've written down the steps here that you need to take in order to be able to fully answer a max or min question. So let's first of all look at the language. So we've maximum and minimum points. And in this picture here, you can see you have your XY axis. Okay. We have a cubic function, just a very quick sketch. This is our maximum point and this is our minimum point. Now, these are also called stationary points and they're also called turning points. You can see why they're called turning points because it's the place in the graph where it changes direction. Okay. Stationary point, stationary means not moving. Okay. And if you look at, I suppose if you look at these functions, when it's at this point, which is called a stationary point, the slope here is 0. Okay, which means like the speed is 0. So it's not moving. So if you were to imagine a football, and if you were to kick a football and when it changes direction, for an instant, okay, when you kick the football and it's about to come back down, for an instant, like a tiny, tiny, tiny split second, that football has stopped to change direction. Okay, so that's why it's called a stationary point, because at that turning point or at the maximum point or the minimum point, it is actually not moving at the turning point. It stops and goes again in the other direction. Okay, we obviously don't see it like when we're looking at football or whatever, we don't notice that, but that is what's happening here. So stationary point, turning point, maximum point, minimum point. In the question, it could be referred to as any of them. So you need to make sure that you actually know the language here. There is steps to follow. And we've covered most of this already between the first video with differentiating and then the rest of it is kind of algebra and solving. So solving, substitution. So again, you can see where algebra keeps popping up here in all of the other sections. So first thing you're going to do is differentiate the function. You're going to let the derivative equal 0. You're going to solve the equation for x. You're going to sub the x values back into the original function. That's probably one of the most important things. Big mistake is that people sub it into the derivative. And then you have your max or minimum point and you need to determine if it's a max or a min. Okay, so let's follow our steps when we do this question. So it says f of x is equal to 2 minus 9x plus 6x squared minus x cubed. Find f prime of x. So first step here is to find the derivative. So f prime of x, the 2 here doesn't have an x, so we're not differentiating that. The minus 9x is minus 9x to the power of 1. So if it's minus 9x to the power of 1, then we have minus 9, and that will be x to the power of 0, which is 1, so it's just minus 9, plus 2 times 6 is 12x to the power of 1 again there, and then minus 3 times x, reducing the power to 2. So that's your final answer to part 1. Find f prime of x. Now, part 2 says find the coordinates of the stationary points. I've put in brackets here max and min. They didn't put it in the question. They just asked for stationary points. And determine their nature. Okay. So what we have to do here is first think about what's happening. This here is a cubic function. And remember, a cubic function, which we did in our functions video, is a function with two curves. Now this is a negative cubic function. So it's going to start by going downhill from left to right and then uphill. Okay, so this is what our original function looks like. So this is f of x. When we differentiate a cubic function, we end up with a quadratic function. Okay, and we're going to be using this now to find the maximum and the minimum point. Okay, so our steps that I wrote down on the previous sheet was step 1 was to differentiate the function, but we already did that. Step 2 is let the derivative equal to 0. So we're now going to let this, which is the derivative, first derivative, we're going to let this equal to 0. So minus 9 plus 12x minus 3x squared, and we're letting it equal to 0. Now, the first thing I will say here is this is a quadratic equation, and we'll usually solve these by using back-to-back brackets, or else using our guide number, or else even minus b formula, which you saw in the algebra videos. We're going to try and make our life as easy as possible. So the first thing I'm going to do here is divide everything by minus 3. And then we will have a plus x squared, which will make us just use the most basic type of solving our quadratic. So we've 0 equals minus 3 divided by minus 3, minus divided by a minus is plus, 3 divided by 3 is 1. So that's a plus x squared. Plus 12x, so we have plus divided by a minus is minus, 12 divided by 3 is 4x, and then minus 9 divided by minus 3, minus by minus is plus, and 9 divided by 3 is 3. Now again, I know we're being fussy here, but I don't like the look of that because it's not written from left to right in the correct order. So we now have f prime of x is equal to x squared minus 4x plus 3 equals 0. And we need to solve this. We need to solve this now to find our two x values for the max and min point. So we're going to solve this by using back-to-back brackets. So x by x gives us x squared. Factors of 3 is only 1 by 3. So we don't have any options here, which makes our life a little bit easier. So we've 1 times 3. So we've 1 times 3. And remember, if the sign of the constant is positive, it means the signs in the brackets are either 2 pluses or 2 minuses. Now we're looking for a minus 4x, so it's going to be minus 3 and minus 1. Now, in our last algebra solving video, we need to let each bracket equal to 0. So x minus 3 equals 0, x minus 1 equals 0. X is equal to minus 3 moves over and becomes plus 3. And x minus 1 moves over and becomes plus 1. Okay, so what we're picturing here is that we have 2 points, a maximum and a minimum point. And at the moment, we only have the x values. Okay, so the x values is like 3 something and the other x value is 1 something. So these are going to be our maximum and minimum points. Now our next step, okay, so we've now differentiated the function. We have let the derivative equal 0 and we've solved for x. We found our two x values. So our next step is to sub the x values back into the original. And as I said, this is a really common mistake. So the original is the function before it was differentiated. So we now need to sub in x equals 3 into this original. So it's 2 minus 9 times 3 plus 6 times 3 squared minus 3 to be cubed. And then on the other side, we're subbing in for 1. 2 minus 9 times 1 plus 6 times 1 squared minus 1 to the power of 3. So on the left hand side we have 2 minus 3 nines is 27 plus 6 times 3 squared is 9 minus 3 cubed is 3 by 3 by 3. Be careful, 3 by 3 is 9, 3 by 9 is 27. So we have minus 27 minus 27 is minus 54. Okay, 6 nines is 54. So we now have 54 minus 54, which is 0. So my answer here is 2. Okay, now what that means is we have 3 and 2 is one of the coordinates. And on this side we have 2 minus 9 times 1 is 9. 1 squared is 1 times 1, which is 1, so we've plus 6. 1 cubed is 1 times 1 times 1, which is 1, but there's a minus in front, so it's minus 1. 2 minus 9 is minus 7. Minus 7 plus 6 is minus 1. And minus 1 is minus 2. So our other point is 1 minus 2. So we've 3, 2 and 1 minus 2 are our stationary points, or our max and min, or our turning points. Okay. Now, you need to determine their nature, and what that means is you can't just leave it there. You need to tell me which one is the max and which one is the min. Now, what we're going to do is look at the y value, okay? Because if you think of the y-axis, if we have a 2 and a minus 2, so imagine this here is 3, 2. And imagine this, even though it's not, because this axis would have to be over here. Imagine this is 1 minus 2. If you look at the y values, the minus 2 has to be the minimum because it's lower than the plus 2. And this has to be the maximum point. There's a lot in that. However, it's a combination of everything we've done before. There's actually nothing new in that. It's important that you remember each of the steps, okay? And applying each of those steps, and just make sure at the end you know the difference between the max and the min. Okay, I'm going to do one more of those. So find the coordinates of the turning point of the curve y equals minus x squared plus 9x minus 14 and determine the nature. Now I'm going to think about this curve again. Minus x squared. Now if we think of our quadratic functions that we did in a previous video, what we have here is a negative x squared. And a negative x squared graph is always an n-shaped graph. Okay? But if you think about this compared to the last question there was 2 points. Okay, so there was a max and a min. This is going to be a little bit different because there's only one turning point. Okay, or one stationary point, or a max or a min. Okay, so let's follow our steps, but we need to keep this in mind. I think it's always good to kind of think about what you have before we get into it. So our first step is always going to be to differentiate. So because the function is called y equals minus x squared plus 9x minus 14, we're going to find dy dx. So the 2 is going to be multiplied, so minus 2x, and remember reducing the power by 1, so it's minus 2x to the power of 1 plus, that's a power of 1, so 1 times 9 is plus 9. And remember that becomes x to the power of 0, which is just 1, and 9 times 1 is 9, and this doesn't have an x, so our final answer to the first step is minus 2x plus 9. The second step is to let the derivative equal 0. So we've minus 2x plus 9 equals 0. Second step done. Third step is to solve this. So we leave minus 2x on the left, bring plus 9 over to the other side, it becomes minus 9. X is equal to minus 9. Remember, minus 2 times x becomes division when it's moved over. So we're solving for x, okay? Solving for x here, we've x equals minus divided by a minus is plus, and 9 divided by 2 is 4.5. Okay, 9 divided by 2 is 4.5. Now our fourth step is to sub the x value into the original. So if x is equal to 4.5, the original is what was given to us at the start. So it's minus x squared plus 9x minus 14. I'm now replacing the x with the 4.5. So we've minus 4.5 squared plus 9 times 4.5 minus 14. So the y value, I'm actually just going to throw this into the calculator because of the decimals. Be careful, the negative is outside. So it's negative bracket 4.5 to be squared plus 9 bracket 4.5 minus 14, which is equal to 25 over 4, and if I press the change button it's 6.25. Now what that's saying here is you have 4.5, 6.25. This is our stationary point, or our turning point, and it's going to be a maximum point because of my picture. Because it's an N-shaped graph, then that's going to be a max. Okay, so I'll send on some questions based on this, but we may need more practice of me doing some of the maximum and minimum questions.